Have you ever looked up at the night sky and wondered how ancient civilizations made sense of it all? Long before telescopes and space probes, a revolution in thinking took place that would shape our view of the cosmos for over 1,000 years. This is the story of Hellenistic astronomy, a time when humanity first tried to measure, model, and truly understand the heavens. The Hellenistic era, following the conquests of Alexander the Great, was a melting pot of cultures and ideas. Greek thinkers inherited a treasure trove of knowledge, meticulous star charts from the Babylonians and the geometric genius of the Egyptians. But they weren't just librarians of ancient wisdom. They were pioneers, driven by a powerful new idea, that the universe wasn't just a realm of gods and myths, but a system that could be understood through reason and mathematics. Imagine the sheer audacity of it. Around 270 BC, an astronomer named Aristarchus of Samos proposed something radical. He suggested that the Earth was not the center of everything. Instead, he placed the Sun at the heart of the solar system, with the Earth and other planets orbiting it. This was nearly 2,000 years before Copernicus. His heliocentric model was a stunning leap of imagination, but it was too far ahead of its time and didn't gain widespread acceptance. Yet the pursuit of measuring the cosmos continued. A few decades later, in the vibrant city of Alexandria, a scholar named Eratosthenes conducted one of the most brilliant experiments in history. He had heard that on the summer solstice, the sun shone directly down a well in the city of Syene, casting no shadow. But in Alexandria, on that very same day, a vertical stick did cast a shadow. Eratosthenes realized that the difference in shadow angles was due to the curvature of the Earth. By measuring that angle and knowing the distance between the two cities, he calculated the circumference of our entire planet. His result was astonishingly close to the modern value. Think about that. He measured the world with nothing but a stick, his eyes, and the power of geometry. These astronomers weren't just guessing, they were calculating. They used geometric principles to estimate the size of the moon and its distance from Earth. They even tried to calculate the distance to the sun. While their figures weren't always precise, the method was revolutionary. They were moving away from mythology and toward a scientific framework, proving that the heavens operated on predictable, understandable principles. Another giant of this era was Hipparchus, often called the greatest astronomer of antiquity. Working in the 2nd century BC, he combined his own meticulous observations with centuries of Babylonian records. This allowed him to create the most comprehensive star catalog of his time, noting the positions and brightness of over 850 stars. He discovered the precession of the equinoxes, the slow, conical wobble of Earth's axis a cycle that takes nearly 26,000 years to complete. Hipparchus refined geometric models to predict the paths of the planets and the timing of eclipses with greater accuracy than ever before. In this world, knowledge became a new form of power. The ability to predict celestial events wasn't just an intellectual exercise. It had practical and social influence. An astronomer who could forecast an eclipse or create a reliable calendar held a position of great authority, advising rulers and shaping public life. This authority came not from divine revelation, but from intellectual mastery of the cosmos. This incredible period of discovery reached its zenith several centuries later with a man named Claudius Ptolemy, who also worked in the Great Library of Alexandria. Around 150 AD, Ptolemy synthesized over 500 years of Greek, Babylonian, and Egyptian astronomical knowledge into a single, monumental work, the Almagest. It was one of the most influential scientific texts ever written. Ptolemy's goal was to create a complete mathematical model of the universe that could accurately predict the positions of the sun, moon, and planets. To do this, he perfected the geocentric, or Earth-centered model. He knew that a simple model of planets circling the Earth didn't work. It couldn't explain why planets sometimes appear to slow down, stop, and move backward in the sky, a phenomenon known as retrograde motion. So, Ptolemy introduced ingenious geometric tools. He imagined each planet moving in a small circle, called an epicycle, which in turn moved along a larger circle around the Earth, called the deferent. By adjusting the sizes and speeds of these circles, he could reproduce the observed motions of the planets with remarkable precision. His system was complex, but it worked. It was predictive, mathematically elegant, and based on all the available observational data. The Almagest was a masterpiece of scientific codification. It provided tables, instructions, and geometric proofs for calculating almost any astronomical event. For the next 1,400 years, it was the definitive textbook on astronomy. If you were a scholar in Europe, the Islamic world, or India, Ptolemy's work was the foundation of your understanding of the heavens. The authority of Ptolemy's model was magnified by the rise of Christianity in the Roman Empire. The idea of a stationary Earth at the center of a perfect, unchanging, and harmonious celestial realm resonated deeply with theological concepts of a perfect, God and humanity's cessal place in creation. The spheres of the heavens, moving in beautiful, predictable circles, were seen as a reflection of divine order. This alignment of science and religion gave Ptolemy's geocentric model an almost unshakable authority. To question it was not just a scientific disagreement. It could be seen as a challenge to religious doctrine itself. In a way, the very success of the Almagest created a closure effect. It was so comprehensive and so successful that it seemed like the final word on the cosmos. For centuries, the main work of astronomers was not to discover new models, but to refine and apply Ptolemy's system. The great story of the cosmos seemed to have been written, and all that was left was to study the text. But the story of knowledge is never truly over. Even as Ptolemy's system dominated, it carried the seeds of its own evolution. Following the fall of the Western Roman Empire, the torch of astronomical inquiry was carried forward by scholars in the Islamic world. From Baghdad to Cairo to Cordoba, they translated, studied, and preserved the Almagest. But they did more than just preserve it. Islamic astronomers were brilliant mathematicians and keen observers. They tested Ptolemy's models against their own, more precise observations and found slight inconsistencies. They criticized some of his geometric constructions as being philosophically impure. Thinkers like Ibn al-Haytham and the astronomers of the Moraga school began to develop alternative models that, while still geocentric, were mathematically different and in some ways more elegant than Ptolemy's. They were reopening the cosmic story, demonstrating that even the most authoritative text was subject to questioning and improvement. They were continuing the Hellenistic tradition of combining observation with mathematical reasoning, and in doing so, they laid crucial groundwork. When the Almagest and the commentaries of these Islamic scholars were later translated back into Latin and reached Renaissance Europe, they provided the tools and the intellectual courage for figures like Copernicus to once again challenge the old model and propose a new one. So the Hellenistic era stands as a pivotal moment in our journey to understand the universe. It was an age of brilliant firsts: the first heliocentric model, the first measurement of the Earth, and the first comprehensive mathematical system of the cosmos. It established a legacy that was codified by Ptolemy, sanctified by religion, and then critically re-examined and advanced by Islamic scholars, ultimately paving the way for the scientific revolution. It reminds us that knowledge is a continuous conversation across centuries and civilizations, an ever-evolving story where every final word is just the beginning of a new chapter. Thanks for watching. If you enjoyed this journey back in time, be sure to like this video and subscribe for more stories about the history of science. See you next time.